So this is our lux meter, and this is the photo detector that is attached to it. It detects the light falling on it. As you can see, the lux meter has two columns for lux measurement. The column in black is for measuring illuminance in the unit of lux, whereas the grey column is for measuring it in FC, that is foot candle. 1 FC is equal to 10.7 lux. Right now, as you can see, the knob here indicates that the lux meter is switched off. Let us turn it on. This here is the data hold button. When we switch on data hold, the value of lux meter gets freezed. That is, it gets stuck to the value it was showing just before switching on the data hold. These are the fast and slow knobs. The fast mode is used when there are quick fluctuations of light in your surrounding, and we use slow when the luminance doesn't change much. Again, the fast and slow options are available in black and grey respectively to measure in lux and foot candle. It also has the output ports to gain any output desired. The model of lux meter we have here is LX is equal to 102 light meter by Lutron. As you can see, we are in a college's ground to test our lux meter outdoors.
At present, the lux meter is switched off. So let's turn it on. The reading starts from 900 and it's around 1000. And we are not standing in direct sunlight. So this is comparatively more of a shadow zone. So let's check out a lux meter in direct sunlight. As you can see, the lower ranges are showing out of range. So let's change the range parameter. We have to keep it at max, that is 0 to 50,000. Showing reading as 1000. So let's hold this data, and from this we can conclude that sunlight is really bright.
Now let us unbox our thermal camera. As you can see, it comes in a briefcase with a set of various components. This is the charger, with the help of which we can charge our thermal camera. It comes with a set of extensions, with the help of which we can plug in anywhere in the world. It also comes with a set of CDs, stickers, calibration certificate, warranty card, and an extensive manual which helps to give us a thorough understanding of the working of the thermal camera and the various options present in it. Let us check out our thermal camera. This is our thermal camera. It is from the brand named FLIR, and here is the charging portal. As you can see here, it is written IR lens f is equal to 6.5 mm, which means that it is an infrared lens of 6.5 mm focal length. This is how you can open and close the lens. The thermal camera is switched off. Let us turn it on. By pressing this button right here, we can turn it on. Be sure to press it for long enough.
So guys, to click images, we have to press this button. As you can see, we have a bulb here which is switched off at present. In the thermal camera, we can see that bulb is not very hot and it's similar to its surroundings. Let us click a picture of it. Let's switch it on. We can see the quick change in thermal picture. The bulb is glowing and getting hotter by the minute. We can see a bright white red spot at the top of the bulb, which indicates it's extremely hot. Let us click a picture. Let's check these images out in gallery. This is for when the bulb is switched on with the bright red spot, and this is it was switched off. This is the normal version of this picture, and in this picture when it was switched on. This is how we use thermal camera to capture temperature of the images. So guys, to open settings we need to long press the button in middle. In here we have various options like image mode, color, temperature scale and some other settings. We will not be changing any of these since these are required for specific experiments. These are measurement parameters, save options and device settings. Let us check out image modes like thermal MSX, thermal, picture in picture, thermal blending and digital camera. Today we are going to use thermal MSX for our experiment. In this measurement tab, we have hot spot, cold spot and no measurement. This pinpoints the brightest spot in picture for us, whereas the cold spot pinpoints the coldest spot of our picture. Then in color option, it shows various gradients like iron, rainbow, grey, below alarm and above alarm. We will be using rainbow. In temperature scale, which shows the temperature across the image, we have two options, auto and manual. In manual, we have to set the scale manually. We are gonna select auto today since it sets the scale itself and is really helpful. On the top, we can see the surroundings temperature, that is 33.3 degrees Celsius. And by pressing this button on left, we can view the saved pictures. For example, in this image, this is a normal thermal vision. And if we press the down key, we see the normal version as well. Let's break down the tachometer block diagram. First is the sensor. An optical or magnetic sensor detects changes in the position of a rotating object, generating electrical signals. Optical sensors may use light interpretations, while magnetic sensors rely on changes in magnetic field. Next up is the signal conditioning and memory. The raw signal enters a conditioning circuit which filters noise and amplifies it if needed. It includes a small memory buffer to stabilize the signal before further processing. Next, we have microcontroller. The conditioned signal goes to a microcontroller acting as system's brain. It converts analog to digital, calculates RPM, and manages data storage. Then we have display. The microcontroller sends processed data to the display unit, conveying RPM visually. It can use a needle, LED display, or other elements on the dashboard. Then the memory. In addition to the buffer memory, the system may have storage for historical data or setting, preserving the information even when the engine is off. Lastly, we have extended port. An extended port allows for expansion or connectivity, enabling connections to external devices for data logging, integration with other vehicle systems, or additional displays.
This is a digital tachometer. It's from the brand named BTEC and the model name is HTM590. A tachometer is a device that measures the rotation speed of an object. We can see a switch for RPM and MPM, where RPM measures rotations per minute and MPM measures meter per minute. While using the tachometer, we can select either one of these options according to our needs. It has a memory to display values stored by the microcontroller. It stores the maximum reading, minimum reading, and the last reading, which can be displayed whenever required.